All right. Hello, everyone. Um, Welcome to the Mobile Development Workshop. I'm Xander. I'm a part of the Club Finity team at SEC. And yeah, I guess we'll get started right away. Okay, so this workshop will be in two main parts. We'll have the first part being sort of knowledge base. We'll go through slides, talk about what mobile dev is, what React Native is, and what Expo is. If you don't know what React Native or Expo is, that's fine. We'll talk about that. And then the second half, we'll do like a hands-on demo. We'll develop a productivity app where you can do to-do lists and notes. So without further ado, first, what is mobile dev? So surprise, surprise, mobile dev is building software for mobile devices. So I think everyone's aware of that. However, before we dive into, let me move this. Okay. Before we dive into some interesting statistics about mobile dev, first, what are some like main milestones that were achieved for mobile development and why it is what it is today? So first, most of you know the iPhone that was launched in 2007. That definitely revolutionized mobile development or just mobile, the mobile platform in general. Then we had the App Store that followed up about a year later. So people can now develop apps for the iPhone. Very shortly after, we actually have the Android and Android Market that released in 2008. Android Market also just being the Google Play Store that got renamed a few years later. And then an interesting statistic, is in 2012, app usage actually surpassed mobile browsing usage. So we start seeing a shift in how people interact with their phones and start interacting more so with their apps. And that is what mobile development is today. So some interesting stats about mobile development. First, in 2023, there was 257 billion downloads, which is kind of insane to think about. We also have around 4.8 million apps on the Google Play Store and App Store. Now, given yes, most of them are probably duplicates, but that's still saying around like 2 million different apps on a singular platform, which is kind of crazy to think about. And then for those of you that are money hungry, there's about $935 billion in estimated revenue in 2024, which is insane. So what is good mobile development? And yes, this might be slightly subjective, but there's still is some ground truth in it. So first, a simple UI. You want to focus on clarity, minimalism. This example here is from Substack, if you guys know about it. It's like a reading platform. You want to make it very easy for the user to interact with your platform, your app. And seamless navigation, the second here, you want to make it very easy for the user to navigate between screens. You want to make it very intuitive, right? You don't have as much mobile real estate or like screen real estate as with the web apps. So you want to make sure you're placing things efficiently and they can navigate your app efficiently in general. And then clear purpose. Apps today have a very straightforward purpose, right? You even have these platforms like Facebook that break up in different apps. You have Messenger, Facebook ads. So when you have a clear purpose, people most likely will have a higher chance of engaging with your application. So what is the current landscape of mobile development? So I was actually kind of surprised by the stats. 72% of the market is Android. And what Android is mainly is Kotlin and Java. Java is like the old way of doing it. And Kotlin is this new language developed in 2010 around. Java's around like 1990, I believe, late 1990s. And that is for Android. The second part, iOS, is 28% of the global market, around 50% of the US market. And for iOS, there's a similar like thing happening here. You had Objective-C, developed, I think, in the 1980s. That was the previous language used. And now we have Swift, that was developed, I think, in 2014. And that is what most apps will use nowadays. So Kotlin and Swift are the new ways of doing things, and Java and Objective-C are the old ways. But we'll see that you don't have to use these languages for mobile development, which is really cool. Then, what kind of apps exist? So there's mainly two types of apps, although you do have some that lie in between. That's sort of where React Native is. You have native apps and you have hybrid apps. So what are native apps? They're built with an SDK. So if you're building for Android, you're building with Android Studio, you're writing Kotlin or Java. And if you're iOS, you're building with Xcode, that's like an ID and all that sort of stuff. And you're using Swift or Objective-C like we just saw. Native apps have generally better performance. They also have access to specific device features. That's why like some people tend to choose it. And we'll look at afterwards why to choose hybrid or like React Native or why choose native. The downfall is if you have one app, you need two code bases, right? If you have one app, you're going to write in Swift and then you're writing in Kotlin, or you can write in Java and Objective-C. It doesn't matter. But you're going to have two code bases for the same app. Hybrid is a bit different. Hybrid runs in web view. So think about it just as your phone is rendering a browser and your app is in the browser. So it uses all your typical web technologies, HTML, CSS, JavaScript. And it's nice because it's cross-platform, right? You have one code base and you can deploy on Android, on Apple. The downfall is that you don't have device-specific features. There is like some bridges and plugins you can use, but it's not optimal. And you have generally worse performance. And it also is something I saw recently that you can't actually run like offline apps, where it's a bit more difficult at least. So that's the landscape of mobile development currently. And where React Native lives is sort of in between, and we'll dive right in right now into what React Native is. So what is it and what's so special about it? So React Native is one way of building apps. It's a library to build native-ish apps. We'll see why native-ish for both Android and iOS using React. So probably most of you know what React is. It's a web development library. It is very, very popular, the most popular one by far. And where did React Native get created? Well, the same place as React at Facebook. It got created in 2013 and then released later on open source in 2015 to more easily build UIs on mobile. So interesting story of how this got created actually. I think it was about in 2013 when the React founder at Facebook he thought that React was just an easy way to create UIs. It was very easy, and he wanted that same experience for mobile. So during a hackathon at Facebook, now Meta, him and two others, I believe, grouped up and built React Native in about like 3 days. And then they presented the whole project to everyone, like all the execs, and later got released and then later got published into like open source in 2015. So it started from a hackathon project, which is pretty interesting. So what are some main characteristics of a React Native app? So first you have that native feel. You'll see that it sort of lies in between of hybrid and native. It's not totally native. You only have one code base, but it does have a native feel. And we'll see how it achieves that in just a little bit. One of the main advantages is that you can use JavaScript. So probably a lot of you use JavaScript, most likely for web developments. So you can use that same language inside of React Native, or also TypeScript for those that use TypeScript. It's cross-platform, so you have one code base and you deploy everywhere. That makes it very easy to do rapid development. That's why a lot of companies will use it to develop relatively quickly without having to write two different code bases and trying to keep it consistent between the both. Another characteristic is fast refresh, and we'll see this in the demo, in the hands-on afterwards. But when you develop in React Native, you'll see that when you make a change in code, when you save, you'll see that change like basically instantly in your simulator or whatever you're running your mobile app, which is really, really cool. It is a unique feature of React Native, and a lot of different libraries nowadays have the same thing, but React Native is one of the first ones that implemented it. So before we dive into like what makes React Native like so popular, first some alternatives. So you might have heard of these. Probably the first one, if any, these two, I mean, I've never heard of them. Actually, that is not right. That's supposed to be Xamarin, I believe. I don't know why. I probably copied paste or something else. So Flutter is definitely probably similar popularity in general to React Native. Flutter was created by Google, and it uses a language called Dart. So you're not using JavaScript, you're not using Swift or Kotlin, you're using Dart. It's its own language. So there is some learning curve to that. Then you have, and that is the same as like React Native. It actually has its own rendering engine, but we won't dive too much into that. Ionic is really that hybrid model, right? We saw it runs on WebView. It uses those traditional web dev technologies. But again, it's not as performant as native apps, so it's not super popular. Then we have Xamarin, not bank transaction. I'm not sure why that appeared there. But that was created by Microsoft. Well, actually, it's owned by Microsoft. I believe they acquired the company. And that is cross-platform again, but using C# and .NET. I've never used that, but I know that it's relatively popular technologies. So that's like the landscape of things. But why is React Native so popular? So three main components here. First, the community. If you've used React Native, you know the community is very, very active in React Native, right? You have a tons of libraries and you have a lot of help online. So it's a great like development experience in general. Similar workflow. If you've used React and you go to React Native, it's basically the same thing. It really is, and it makes it so quick to develop something in React Native. So if you're used to React or even just using web technologies in general, you'll find it very, very easy to transition into React Native compared to like going to Flutter or that sort of technologies. And then native performance, we'll see that React Native acts as a way to make it so that you have a native-ish feel with the performance. They convert components to native components, and we'll look at that afterward in detail. But you do have that like sort of native performance. It's not as good as a native, but it's one of the reasons why React Native is so popular nowadays. So, like I was mentioning, how is React Native native? So, on the left here, you see, we have certain components here in React. This is a React Native app. So you have this view component, this text component, this image component. And what it does basically is at runtime, it converts these core components. These are all called core components. We'll look at them after in detail into the native version of those components. So a view of React Native goes into a view group for Android and then a UI view for iOS. So it goes to the native specific component, and that's why it makes it feel like the app is native. Unfortunately, not all components are going to be converted natively, but most of them are going to be, at least these core ones. So yeah, the image, the text, there's a bunch of different components, and we'll look at some examples afterwards. But this is how React Native becomes this like a native-ish app. It is a mix of JavaScript and these native components here. So yeah. So you have all those components. You're able to convert them to native components, which makes you pretty good. There's a good user experience in general. What is the workflow like? So, like we say, you have one code base and you have two platforms. The thing is, to deploy on iOS or to deploy on Android, you're most likely going to pass by these two tools. So this is Xcode, for those who don't know. This is for iOS, and this is Android Studio. When you, for example, when you deploy to iOS, you have to pass through Xcode. So your normal development workflow is going to look like development, testing, or being React Native. And then when you're ready to publish your app on the App Store and the Google Play Store, you're going to go and do two steps, go through Android Studio and go through Xcode. Now, this looks relatively simple, but it really is not. And we'll look afterwards why it's not and how you can fix this via Expo. And we'll look at Expo afterwards too. But this is like a high level abstraction of what the workflow looks like in React Native. So who uses React Native? I was actually surprised to see some of these. Apparently, Amazon Shopping uses React Native. Discord uses React Native. Walmart, PlayStation, Tesla, Outlook, all these companies use React Native. This is kind of funny because Microsoft owns Xamarin, but they use React Native for some reason. And there's also, if you guys later access the slides, a link here from React Native Dev, I believe, with all the different companies that use React Native. And there's an extensive list. So this is like a reputable technology for people to use in mobile dev nowadays. Now, we will see that there are still some people that do not use React Native and they use native. And there is a reason why. When companies have a lot of money and they have like enough developers to work on, they might choose to go native. And we'll look at the reasons why afterward. But first, React Native. Why would you go and develop your app using React Native? Well, first, the development speed, right? Like we mentioned, there's one code base. So you maintain one code base and you have your application deployed everywhere, which is really, really useful. Next, you're using the language you probably already know, JavaScript. So that makes it very, very easy to just transition from like a web dev flow to a mobile app flow. You're also, it's more easy to like maintain your UIs across both because again, you have one code base, right? So it makes it very easy to make sure that what you see on Apple or iOS is very similar to what you see on Android. And that is a bit harder with native. So with native, you do have better app performance. We looked at that before, but it is much, much harder to have a consistent UI across both. Like you're gonna have to collaborate between teams. But again, this is more so for like big companies that have a lot of budget, that sort of stuff. You do have access to all like the full range of device features, which makes it makes a very smooth experience. You might see companies transitioning from like React Native to native once they have enough developers on their team, and general like an improved UX experience, right? Because of those native features, it just makes the experience better in general. So React Native, the core components. So like I mentioned, there's a few components, well, actually quite a few, that React Native have built that transition from this like JavaScript to these native components. So these are a list of all like, well, some of the core components. It's not the whole list, but as you see, there's like quite a few of them. So in general, what you have like, remember, React Native is Reacted in the day. So you have some React components that you use. So there might be some things that you use in React that you'll also find in your React Native workflow. Then you have React Native specific stuff. You have your core components, which are these. These are provided by the team, and you'll mostly use these. Then you have your community components, so all those third-party libraries you'll use. Then you have your native components. But the main ones you want to focus on are these core components, which you'll probably use like view, text, touchable opacity is not here, but we'll look at that afterwards. So all of these, and some are used for lists, some are used for Android, iOS specific, some are used for UI, other. You have a whole list of them, and you can use them and ultimately provide a native-like experience to your users. So some examples of how you might use them. So this is what a React Native, a very basic screen might look like. So you're obviously importing the components, and then you're just declaring them here. So notice how in React, if you use them, you've used React before, you're using HTML, right? You're using div, span, button, but not this type of button, a different type of button. Here, you're not using any HTML, right? You're only using these core components. So you're declaring a view. A view is just like a div, think of the div. And then using text, and then using button. And all these are core components. So if your app is just this, realistically, your experience is going to be pretty much native once you deploy your app on iOS or Android. So this is how you're usually going to develop a React Native app. And this is a functional component. There are class components, but you probably shouldn't learn about them just because they're also deprecated. People usually use function components. So this is the general structure of what a component might look like. You'll have your return value here, and this is what you're rendering. And above it, you can deploy call any variables, like state variables you might know about. But yeah, that's like the basic structure of a React Native app. And here you just have a view, text, and a button. Very simple. For styling, so for styling, again, this is sort of similar. But again, like I mentioned, you're not using these HTML tags anymore. You're using only these core components or these community components, whatever. And then again, for styling like the CSS, you see it's slightly different how you call it. But again, if you're using something like Tailwind CSS for like we did workshops to Rob last week, you won't be using this. You'll be using inline styling. But this is generally how you're going to style your components in React Native, and it's slightly different from like React or traditional HTML and CSS. Some other examples of what it might look like. For example, if you have a text input, right? Again, we have the view, we have the text, and you have a text input here, and you declare all these values. So it's very similar to HTML. I actually find the workflow even more easy to get on to use. But again, that's sort of a personal preference. But again, once again, using those text input as a core component, it'll transfer to the native component once it's being deployed. And finally, last example here. This is a bit more involved. So here you have a touchable opacity, which this is very commonly used. Think as a touchable opacity is like a view, but that can be clicked. So whatever you put in it can be clicked. So for example, here we have a touchable opacity, and inside we have an image of Clubfinity. Well, no, sorry, the SEC logo. It's wrong. But once you click it, you can have this on press just like any other button, and then you have this alert that pops up on the screen. And again, alert is one of those core components. So this alert might look different depending if you're on iOS or Android. That's the idea of core components again. That's it for React Native. Probably a high-level overview of what it is, how you develop with it. So now what Expo is. So Expo, if you were to React Native, you probably heard of Expo. They sort of go hand in hand nowadays. So what Expo is just a way to enhance your workflow with React Native. And it's sort of become a standard, to be honest. So Expo is just an open source framework to build, deploy, manage your React Native app. This was created in 2014 to sort of streamline the process of building cross-platform apps with React Native. And some of the main characteristics you see with Expo, first, the ease of setup. So we'll look at it afterwards, but you do not need Xcode or our Android Studio. If you didn't use Expo, for example, if you didn't have a Mac, you probably couldn't even deploy to the iOS, like the Apple Store, because you need Xcode to deploy to the Apple Store. With Expo, you don't need that. So you can be on Windows and deploy to Apple Store just fine. Then you also have a managed workflow. So we'll see there's a bunch of different steps. They basically take care of everything from development, deployment for you. They make it very, very easy to build something cross-platform, and that's consistent and always works, and it's not always running into bugs. We'll see some issues that you can run into without Expo. It has a bunch of built-in libraries and APIs. One thing I mentioned is that if you're using native, right, you have access to all these device features that you do not have with hybrid. Expo has a suite of these tools you can use, which makes it so that you can access those features very, very easily. And we'll look at in the hands-on example, some examples of that. And lastly, a large community of developers. If you use React Native, you almost always use Expo, except for like a big company and you have your own pipeline already set up. But there is a large community of developers for Expo, so you're gonna have a lot of help online when you're building your app. So Expo, and this is, I guess, not objective, but this is sort of my point of view of what the different products are that you use with Expo. So first, the Expo CLI. So the Expo CLI just allows you to interact with Expo in your terminal. So you can create a project using, for example, npx expo create, well, npx create Expo app. This you'll probably just use to instantiate the project, not much more. The SDK is really one of the main products you can use with Expo. And this will just allow you to access those device features. Like we said, like you might access local device memory storage, sorry. You might access like the camera app, you might access the GPS. All of those features are enabled via the Expo SDK, and it's actively maintained. And also make sure that your workflow is consistent. Like it'll make sure that your React version is compatible with the latest iOS or Android versions, that sort of stuff. Testing. So Expo Go is an app you can download on the App Store, the Google Play Store, and it allows you to test your changes in real time. So for example, if you're running a React Native app, you can either have like a simulator on your computer, or you can have it just on your phone. You like download the Expo Go app, you scan a QR code, and you have the app on your phone. So you can also develop that way. And finally, Expo EAS. So that's just a service you can use to like streamline your whole deployment process, your build and deployment process. So it is like a software as a service type of thing. So you do have like, it's like a freemium product, but the free tier is plenty. That's what we use at Clubfinity to deploy our apps. So these are the 4 categories of things that you'll use with Expo in general. So what does deployment look like with Expo? So before, you'd have to go through Xcode, through Android Studio, all these sort of things. Now you really have 2 different flows, and you most likely will never even use this flow at the bottom here. But the main flow is just, you have your React Native code, you'll go in your terminal, you write EAS build, it's going to build your Android and iOS versions. That's it. You have your binaries ready, and then you just you just type EAS submit, and there you go. You're submitted to the App Store and the Google Play Store. From there, you can do all your setups, like the screenshots for the App Store, and all sort of stuff. But you basically run 2 commands, and your code's on the different platforms, which makes it super easy compared to the other workflow. We'll look at briefly on a high level what that other workflow might look like. Now, one thing to point out is Expo has one major limitation, is that it doesn't support all libraries. There might be some libraries, third-party libraries, or like native code libraries that you want to use, and they're not compatible with Expo, not right out of the box. So what you used to do before is you did this thing called Expo eject. All it would really do is take your Expo project, React Native project, and split them into the native workflows. And from there, you could add in those native code that wouldn't normally work with Expo. The problem with that is that once you Expo eject, you are no longer compatible with the Expo ecosystem. You can no longer come back. Now what you do is, if you need a native dependency that's not supported by Expo, you just use this new command. I have never used it, but it's pretty new. It's Expo prebuild. And from there, you can like write in different plugins to interact with the native code. And then you'll continue the workflow just as normal. You'll build and you deploy. So although there is that limitation of certain libraries not compatible, and you might run into that issue if you develop with Expo, though it's relatively rare nowadays, you can use this workflow. So you can still use Expo even if something is not natively supported with the whole ecosystem. And I believe this is the last slide. So just what is the advantage of using Expo in general on a high level? And again, this is more so for deployment. You still have all the SDK features that you can have. If you don't have Expo, this is sort of the graphic I found that it sort of explains the deployment process. You might run into a bunch of different issues, most likely like compatibility issues, like React updates. If community models that's not supported by the latest Xcode or Android Studio versions, you might have like new OSs or SDKs released by iOS or Android that might not be supported. All those things, you'll run into those issues in deployment. And again, you'll have to separate. You'll have to go through Xcode to deploy here. You have to go to Android Studio to deploy here. It's a pain. With Expo, now given this, I'm not a huge fan of this graphic, but it does explain sort of on a high level. You have these virtual machines by Expo, and they take care of everything, right? So when you run EAS build, it'll go through the virtual machine, it'll build everything on their end, and then you EAS submit, and they'll just submit right away to the different stores, the Apple Store and the Android or the Google Play Store. So it makes everything so much easier. And really, if you're using React Native, there is no reason you should not use Expo at this level, unless you're a big company and you have your whole pipeline set up and that sort of stuff. And this is just an insight of like what the dashboard looks like for us at Clubfinity. Like you see, we have deployments, submissions, and here we have like builds that got finished, and then we also have submissions to Apple Store. So everything is there for you in the dashboard. It makes it very easy to keep track of your builds, your deployments, and all that sort of stuff. With that being said, that is the end of the slides. Now we'll dive into a hands-on demo. So for this, what I'll do is, I do want to like warn you guys, it's not like a I code, you code, the same type of thing, just because that might get like messy and we might like lose track of some people, as well as I won't be able to cover as much topics as if I just did it myself and you guys watched. So I do have a full guide for everything. So on your end, you can go and there's two versions of the code base, one that has the full solution and one that has like these like empty parts that you add in. So we'll do the second part. We'll do the empty part today. We'll add in different versions until we like different code snippets until we have the final version. But that's how we'll do it for today. But again, you can go back and look at the full solution afterwards. So let me get it set up real quick. Okay. So this project, what you see on the left here is just a React Native project. This will look basically the same. Just close that folder. Basically, you say when you do Expo create app, you're basically going to have exactly this. You're going to have I don't know if you have the utils right of the, but you have an app.js, you have the package JSON package lock, again, similar to React, the packages. You have the screens, you have the components. So it's very similar to React project. We won't go too much in detail to that. But then you have app.js, which is like the entry points. And there already is some like boilerplate code I put in there. And we'll go through some of that. We won't go through some of the other stuff. But we're gonna like incrementally build this app. And again, the final product is going to be a like productivity app. You can do a to-do list as well as take notes. So it's very simple. It's all offline, no like connection to a DB, that sort of stuff. Yeah, so we'll go ahead and get started. We'll start building incrementally. And real quick, I do want to note that I'll be using an iOS simulator. So this is in the guide, but if you're using Mac OS, you probably want to use an iOS simulator just because the development experience is much, much better. If you're on Windows, you want to use an Android simulator. But you can also just use your phone and just like scan a QR code. We'll see when I run a command here to start with a QR code, you can scan with your phone and just have it on your phone right there. Just you develop, you save, and you see the new changes on your phone. So that's another way you can do this sort of when you develop with React Native. So with that being said, I'll go ahead and run this. Okay, so again, to run the project, we run npx expo start. This is also in the full instructions, which I'll later send out. But you can I got disconnected. Okay, so forget what I was saying, but we'll just go ahead and run it on the iOS simulator. So I run npx expo start, and you can see here, once I run npx expo start, we get a QR code. Again, if you're using your phone, you just download that Expo Go app, you scan this with your camera app, and then you'll launch directly in the app, and you can have your code or like the finished product in your phone. But I'll be using a simulator, iOS simulator, real quick. I have a list of simulators that I have. And again, you can have different like iOS versions. Like I think they're all in 17. This one's on 16.4. But I just have one that I always use, Clubfinity. That's what I use when we develop our own product, Clubfinity here at SEC. But as you see here, we have the simulator on the right. There we go. Okay, I think we see decent enough. Okay, so right now we have a pretty bare bones project. We don't have much, and there's a few things we'll go over. Um, Let me actually pull up the instructions. Okay, so there's a few things we'll go over, like some main topics. What time is it right now? It's like, okay, we might not have time to go for everything, but we'll try to. So, uh, one thing that's very, very common in apps, you might think. So, to start off, we'll go through navigation. So, you probably notice in basically every app nowadays, you always have this bottom tab navigation, right? You have these different screens you can access, like I don't know, like messages or profile. You always have a tab navigation, bottom tab navigation. So we'll create one of those because again, we'll have to-do list and we'll have our notes. So that's the first step. And then we also have another type of navigation, which is a stack navigation. We'll look at that afterwards. But we'll start by creating that bottom stack navigation right away. So you might, the Zoom might not hear me as well, but I'll try to explain. The first thing you want to do is see that this app is our main entry point. And we have a few like wrapping components. We have these gesture root view, this bottom sheet provider. You can read the comments in your own time if you want to learn about this. This is used for this model component, which we'll look at, we've implemented. Don't really worry about it too much. Just know that right now, basically I have nothing. We have this status bar component, which is displays the status bar for the, depending on your OS. In this case, it's just this, like this, some of the time and the Wi-Fi and the battery, all that stuff. But we have nothing else in the app. So the first thing we're going to do is we have this components in utils called App Navigator. Now, what you might, this is very common. For navigation, you want to create your own components. And from here, we'll build out how we want to do navigation and how we connect the different screens in React Native. This is very different from if you use like React and use like routes. So the first thing we'll do is everything here is labeled, like step one, part one. You follow the instructions, you just copy and paste the code that's listed there. So we create this bottom tab navigator, and this uses the React navigation library, which is pretty much like the standard library to use React navigation in general, like navigation in React Native. But once we created that base navigation, we'll go ahead and create a bottom tab navigator. I'll try to explain each part as we go. Okay, so what we have right now is the bottom tab navigator. So we have the general navigator. We have some properties like the height of our header, and then we have two screens. We have the to-do screen and we have the notes screen. These are already created. These notes and to-dos, they are already created in the screens folder, but we'll look at and we'll complete those afterwards. But the idea is that we're creating two screens in the tab navigator. And if I save, we won't see anything yet because we haven't implemented these changes in our main app component. So now if I go app.js, remember, this is the main entry point to our app. Go ahead and add this part in. And there we go. Now we have this bottom tab navigator. So again, you have to create those notes and to-do screen, and they're very bare bones. They have nothing inside of them except this button. So we have our notes, and if we go to the right, we have our to-dos. And to-dos, you have, oh, notes, sorry, here is you write your notes, and then for to-dos, we'll go ahead and press plus. So right now, there is, sorry, the model already implemented. So this is where we're going to add our to-do. This is already implemented, but like adding a to-do is not. But don't, if you want to look into the code, it's there. Everything's commented for you to like understand what's happening. But we won't really cover how to implement this. If you are curious, though, it uses a library called Gorham Bottom Sheets. Again, kind of like a standard in the industry nowadays when you want to use one of these bottom sheets, also called models. So that is that. Now, that is one type of navigation. The other type of navigation is stack navigation. So think of stack navigation like when you're on a screen and you click on a button and it brings you to another screen. And like you're going into navigation and you can have like maybe a back button in the top left that goes back to the other screen. That's stack navigation. So those are the two main types of navigation you might see in mobile apps. This like bottom tab, you also can have top tab, and then the stack navigation. So what we'll do is that to-dos, they're all going to be in this one screen. So to-dos, yeah, they're all going to be in this screen. So we won't have stack navigation here. For notes, though, we're going to have our notes. And then when you click on a note, we're going to go to an editor. and the editor will allow us to modify those notes. So for that case, we are going to use a stack navigator because you're going to click on something, it's going to bring you to another screen, and you can go back to the previous screen. So we'll create that right now. So I go, and similar way to how we did the tab navigation, you'll start instantiating it at the top here. There you go. And then you'll just create your stack navigation. There's already the function here that's defined. Use that to there we go. So again, stack navigation is very similar to how we created the tab navigation. We have this navigator at the top, and you just have some general properties, and then you have two screens. So you have this notes, and then you have the note editor. So we have two screens of that. So right now, our navigation is tab navigation, to-dos, notes. Inside of notes, you have a stack navigator for notes and notes editor. So it's kind of like this like tree thing. You have two, and then that branches out in two again. And don't worry too much about these header properties. This is just because if you don't put header shown false, we'll have like two headers for each navigator. But again, if you want to read the comments for that, you can do that on your own time. But now what we're going to do is that we've created this, but we haven't actually implemented it. We haven't introduced it to our main nav. So what we want to do is the top screen. Right now we have to-dos, okay, and then we have notes. The notes right now is just accessing straight up note screen. So now what we're gonna do is just replace notes with this note stack screen. That. There we go. So now what we should have is we have our battle time navigation, just like before. If we go to notes, though, I click this, we're brought to this other screen. We're brought to this note editor screen. So now we have three screens: to-dos, notes, and note editor. Okay, and to-dos is on its own, and then we have this stack navigator. So if I got to click done, actually, I don't think it's not going to be done, but if I swipe left, this will bring back to the notes screen. So that's that stack navigator right here. We click this add new notes. We go to this note editor, and if we want to go back, we just swipe back. Eventually, we'll implement the done button, which will bring us back to the notes section. But for now, we'll just have that. Okay, so we're pretty much done with like navigation in general. Now we're going to go ahead and implement these screens. So what we'll do is, next step is for to-dos. So if I open the to-dos, the to-do screen is this. All right now is we have a blank page. So this is the blank page, and we just have a button. And the button opens this model, which is, you probably don't really have to worry too much about it. But the first step we're going to do is, let's look at how we structure to-dos. So to-dos right now are just four properties. That's not to-dos, is it? That's notes. Okay. To-dos have three properties. To-dos have an ID. So you have this random, this UUID, this random generator ID. You probably never have a similar one. Task, you have like this what you want to do for the to-do, and then you have a state like completed. Is it completed or is it not completed? So just three properties. I mean, right now we have some like dummy data that we want to use. But the first we want to do is for a to-do screen, we're going to use a section list. Sorry. A section list is just, think of it as a list. So you're just going to display a bunch of things, but you're going to divide your items into different sections. So in this case, we'll have two sections, active or completed. Whether a to-do is still you have to complete it, or whether you already completed it. But for us to build that section list, we first have to create this object called sections. And this is you don't have to do it. The idea is that now what we're doing, and this is very, very JavaScript like specific. So if you use JavaScript, you know about this. If you haven't, then this might look a bit weird to you, but the idea is that you're building two objects, active and completed, and then you're filtering all the to-dos based, okay, if they're active, then they can't have completed. Completed has to be false. If they're in the completed section, then completed is obviously true. And the section list has to have, for each section, a title and then data. So that's just how it's structured. So we're just building an object here so that our section list object doesn't become cluttered and weird afterwards. So now what we can do is create a section list object. So go ahead. And right now we just have a view, and then we have a touchable passing. Remember, touchable passing is like a view with a button. In this case, we just have this plug button. So what we'll do is step one, step two, part one. We'll add that section. Now what we can see is we have a visuals of our to-dos. We have this active, and it doesn't really look too good. And we'll improve that in just a little bit. But we see everything. But again, we only have active. We don't see completed right now because all of our to-dos were initialized to false completed, right? So we'll change that afterwards. You'll be able to go from completed to not completed, and the inverse. So the next step for us here is to complete a rendering item. So right now, I think we can all agree it looks pretty ugly. It just pretty much just shows the to do, and you can't really interact with it in any way. So what is very common, and this is common in React and probably many other like UI libraries, is that you separate things, right? So in our section list right now, if you look for each item we render, right, we're just rendering text and then we're rendering the task. That's why it looks pretty bare bones right now. But the idea right now is that we're going to change this line 60. We're going to change that so that for each item, we're rendering a special component. And this is a very common pattern where if you have one of those components that you might want to reuse in other screens, you declare it inside the components folder. So you see here we have checkbox, no item, to-do model. To-do model is that thing that pops up that we looked at before. To-do item is what we'll focus on right now. So we're going to create an object that we can render specifically for each to-do item, and it will look much nicer. So there's some boilerplate again in that, most notably the styling. So we won't really look into that, but we also have some styles, and we have this view that is just wrapping everything. But we'll go ahead and implement that. Okay, so what is our to-do item now? We see that we don't have the changes just yet, but basically our to-do item is just a checkbox item. This is again a custom component. We won't look too much detail to that, but again, it's a component. We might reuse that across different screens. So we have a checkbox. We have the text for the task, and then we have a touchable passage again with an icon. It's going to be an X, so you can delete. So you have three things that we can do with a to-do. You can add a to-do, you can check a to-do, or you can delete a to-do. So this is just the to-do item, and we'll reuse this across the board, across different screens. In this case, we're only using it in one screen. But that's the benefit of instantiating in like its own folder components. So now we've finished this to-do item component. We just want to now implement it across our section. So if we go back for to-dos, again, this render item here, if we're rendering that item, we just replace this text part. Now, right, this. Oh, okay. So now, for each item, okay, we're not rendering just text, we're rendering this to-do item. And we're passing three different things to this to-do item. We're passing the item, so the to-do item, and then we're passing two functions. So if you use React, again, this is very similar to how you use React. You pass functions like callbacks so that in this main component, we've defined this handle check and handle deletion. We're not implemented yet, but we pass them over to this render item, to-do item, so that when you press this button here, and when you press like the button on the left or right, it will do a certain action. So we're passing those functions so that they can be called inside of to-do item. So right now, if you click on it, it doesn't do anything because we haven't implemented this handle check and a handle deletion button. I think that's what we're doing right now. Yeah. So if you look above, we do have the basic boilerplate for it. Handle check and handle deletion. So what we're going to do here is talk about states. So if you use React again, you probably know what state is. I'm just going to put this one in. Yeah. So states, I'll quickly go over it because I know we probably covered it on React Workshop. But state is just a way to keep track. Like once state changes, a re-render happens in your screen. So in this case, our to-dos are states, our use state, we declare like that. And every time a change happens, our screen is going to re-render. Okay. So what does handle check do? All handle check does is you're passing an ID in as a parameter. You go through all the to-dos. If you go through all, you map through all the to-dos. If the to-do ID equals the ID that we passed in, we just make it completed to the opposite value of what it is. Okay. So Now what should happen is if I click this, there we go. So I click the item, I checked it, I change the state completed to false to true, and now we have 2 seconds, right? Remember, we declare this object sections here. Where is it? Sections here. So now we have active and completed. So now you have a way to check items. And we'll do a very similar thing to how we did that for deleting. So now, if we just add in the code for deletion, so in handle deletion, we do a very similar thing. We map through all to-dos, we filter, and we just say, okay, we want to keep all to-dos except for the one that has the same ID as the ID we just passed in. So now, normally, if I click the X button, there we go. So now we delete a to-do. So again, we're using state for this. So now what we got, what we want to do is we want to add a to-do. So right now, if you press this plus, okay, and if I type something out here, type random text, and I do add task, this does absolutely nothing because the handle this handle add to do function has not been implemented yet. So we're going to go ahead and add the code for that right now. So again, the boilerplate is already there. All you have to do is snip it here. So real quick, what does this add to do function again? It's pretty straightforward. You first create a new to do object. So we're given input from that model component, the bottom sheets. Then you want to generate a new ID using this UID library. And then you want to put completed to false because obviously you want to start with it not being completed. And then you just append it to the state, right? We go through state, we keep all this previous stuff that was there, and then we just append it to the end. That's all we do basically. So now if we save this, and I add something here, there we go. So now I type something out, and now we're calling this, we're creating this new to do, and we're setting it in the state. So now we can hide items, complete items, and I can delete items. So we're almost done. Good to do. Now, one thing that's like optional is that right now we have nothing. We have a like bare screen, like it shows no indication of anything. So what we might want to do is empty it, like render something in case we have no to do. So for this, I believe just put that here. We have this render here, and we're just going to pass it in this component. So the section list takes in a component called list. Well, it takes this property called list empty components. And all this is going to do now is that if there is nothing in our section list, we have no to-dos, we're just going to render this empty list. We're just going to render this style, this view with this empty container style, and then just press the plus button to get started. So we're almost done with to-dos now. The only thing you might have noticed is right now we deleted all the to-dos, right? We started with 2, we deleted them. If I refresh, and that's just, you press R in the terminal, you see that my 2 to-dos are coming back. So we're not saving anything. Like we don't know what we relaunched the app, we deleted our to-dos, we completed some, we come back, we get back exactly where we started. That doesn't make a lot of sense, right? You want to keep track of your progress over time. So how do you do that? So now we'll talk about Expo SDK. So Expo SDK, remember, is a way to interact with these device-specific features like the camera, like the GPS, and also the device local storage. So what you might do is every time a change happens to state, right? So we have state above there, and we have a use effect. So every time something happens to state, we have like a hook that like goes ahead and gets called. What we can do is we just stay in local, we can save in the local storage all those to-dos, our latest changes. So that way, we don't have to connect to like an online database. Everything is completely offline, only in your device. So to do that, if you're running natively, right, you're writing like Kotlin or Swift, you probably very, very easily do that. With Expo, you can also very, very easily do that with React Native. So we'll create 2 functions first to start off, called save storage and load from storage. So go to our utils, and the utils, if you guys don't know, anytime you have a function or something like the app navigator, in this case, not really a component, but something that you use throughout different screens, like functions, not like straight up like rendering components, you'll just put it in this utils like folder. You can also put like in lib is another common pattern. But in this case, created this file called storage.js inside of utils, and we're just going to declare some functions in here that we'll use throughout our code base. So if state storage, so what we're doing here is we're using this React Native async storage. So we're using, it's actually from Expo. And the idea here is that we're passing data. So in this case, state, right? We have our list of to-dos, and we're passing a type. And all we're doing is that we're serializing our data, our string of, serialized data. So we're making a JSON object from our JavaScript object because that's better stored across device storage. And then async storage is accessing the local device storage. We're just setting an item. So we're like, think about like a hash map, right? You have this key and you have a value. Same thing here. The type is just going to be like, we're going to put like to-dos. So we're going to save the type, our key is going to be to-dos, and our value is going to be our JSON object with all of our to-dos. So that way we can keep track of our progress over time, right? Our latest to-dos are always going to be in our device local storage. In the same way, how we save something, we can also load something. So I go here, I save this. Now we're getting the item from async storage, right? We're getting it. Then we're making sure again if it's not null, and then we're just parsing JSON. So we're going from JSON to a JavaScript object, which we can then put into our state. So we can now use these functions inside of our to-do screen. So here's a section at the top, section step 2, part 8, part 9. We can use a use effect hook. So I'll implement this and I'll talk about what it is. Okay. So a use effect hook, again, this is very React specific. It's just going to be something that triggers every time a certain dependency we put. So in a use effect, we have this function, and then we have this brackets here where you put dependency. If you put nothing inside the brackets, that means that this function is going to happen every time you load in the first time, like your screen is mounted. So what we want to do is every time the screen is mounted, right, we reload the screen basically. We call this load from source function. We put the to-dos, and then we just set our state to be that value we retrieve. So we fetch from the local device storage, then we set our state to whatever we retrieve. So now when we come back into our app, for example, like we loaded it, we did all this stuff, we close it, come back to it, we'll have our latest changes from the local device storage. Again, now you load it, now you also have to save. So when you save, very similar thing, except this time you see the use effect has a dependency. So he has this to-dos dependency right here on line 38. So every time to-dos changes, right? State always changes. Every time we add something, we check something off, we delete something, that's going to trigger this hook. So now every time to-dos changes, we trigger this hook. And if to-dos exists, we go ahead and save it to storage. So let's say we start with two things. We check one off, we add a task. Those two are like events that will cause this to trigger. And then we'll have the latest, like, okay, what are our latest to-dos after these two events? And we'll save it to storage. And then we come back around, we'll load them from storage, and we'll have our latest changes. So now, if I run this, everything should work. So we'll start with 3 here. Okay, maybe I'll create another one. Okay, and then maybe I'll check this one off. Check this one off. Maybe, yeah, I'll just keep it that. We have 1 active, 3 completed. If I refresh beforehand, we just reset to the 2 we started at the start. Now we should have our latest change. There we go. So we still have 3 completed, and we still have 1 active because again, we stored it to a local device storage and we retrieved it upon like restart. So that's how you can have a completely offline app, right? You're not connected to the internet. You're not connected to anything. You're just using your local device storage, which is a pretty cool thing. And again, you don't have like API calls or that sort of stuff. So everything is completely local. So there you go. You finish to-dos. You have the full to-dos section. Now you can add a to-do, you can delete a to-do, you can check a to-do, and there you go. So it's already 7:30, so we won't have time to go over notes. But let me quickly show you what it looks like at the end product. And if you want to, there's a guide that goes through every single step for the notes section. It's very, very similar to what we just did. Except it's obviously the UI is a bit different. But let me quickly boot up the finished product just to get. again, we're loading up Expo chart, and then we're just going to start it on an emulator. So the finished products, go ahead and just, it's going to build up. The finished product is very, very similar for to do. Well, it's actually, we finished to do, so it's exactly we had it. Except for notes. So notes here, basically, you have a list of notes, and you can create a notes, and then you can put like a title for the notes, and you can start like type it, you put, whatever you want here. It's a very bare bones note. And then you have like done, you have a new notes, you have the latest time it was modified, and then you're just ranking them by the latest time they were modified. And yeah, that's pretty much the notes section. The one interesting part of the notes section is this copy. So we also have delete. So if I delete this, obviously delete that. Copy here uses a very like same thing as the async storage. It's an Expo specific library. So you're accessing the device features again using Expo SDK. So that's one of the reasons why people use Expo, because you have access to those functionalities. So if I press copy here, let me just type a bunch of random stuff. Okay, if I do copy, you'll see that if I go, for example, in reminders, and I do a new reminder, and I go and copy that, we have basically the exact same structure as our note, right? So we had our note, we had our title, we had a note here, and we just copied it over. So that, again, we're using device features thanks to Expo when you have those easily implementable. So that is it. That is the Notes app. If you want to implement it, the full code base is already there. You also have the guided version if you want to guide through it and build it on yourself. But that is that. So the demo is complete. Yeah, that's all I have for you guys. So thank you for being here. If you have any questions, I'm happy to answer them. You can just come over and I'll try to help you. Yeah, thank you.